So this video is on it's an explanation video for further mathematics written examination 2 for year 2018, and this focus on the topic of recurrence and financial modeling. It starts from page 11, question 4. So our question 4, first part of question 4, how many dollars does Julie initially invest? First information, so that's my V0 and this equals to $12,000. So I can write my V0 equals to $12,000, or I just write $12,000 over here. Now it says write down a calculation to show that the balance in the account after 1 month V1 is equal to this amount. So I need to write down a calculation. So I'm looking for a number sentence over here to prove that my V1 is equal to that. So from the equation, I know that my Vn plus 1 is equals to 1.0062 times Vn. So if my n plus 1 equals to 1, then my n is equals to 0. So in this case, if I want to find out V1 with n equals to 0, so that's equals to 1.0062 times V0. And my V0 is equal to 12,000, so I just need to write 1.0062 times 12,000, and that's equals to the number given over here. So next question is after how many months will the balance of Julie's account first exceed this amount? So we identified that this is a geometric sequence. Now the geometric sequence equation is Tn equals to A times r to the power of n minus 1. So my to find out after how many months it exceeds this value, I want to first find out at what time the number is equivalent to this number over here. So I want to find out what n is when t is equals to 12,300. So t is equal to this. My a is my starting value, so it's my V0, so that's 12,000 over here. My R is the ratio of my second term over the first term. So it's basically my Vn plus 1 or Vn. So in this case, it's equals to 1.0062. So times 1.0062 to the power of n minus 1. So and I find out that my n minus 1 is equals to my n minus 1 is equals to 3.99501. So my n is equals to 4.99501. So the fifth, and we can say it's roughly equals to 5. So the fifth term and speed earlier than the fifth term, so it's equals to this number. But it asks after how many months. So after how many months, it's actually asking us what is the n minus 1. Okay, so because our initial term is V0, and that's my first term. So after 1 month, so that's going to be my second term. After 2 months, it's going to be my third term. So my term is always one larger than after this amount of months. So if my n is equal to 5, then it's going to be after 4 months. So if this I'm talking about at my fifth term, the number exceeds 12,300, then it's going to be after 4 months. The number is going to exceed 12,300. Part C say a rule of the form Vn equals to A times B to the power n can be used to determine the balance of Julie's account. So this question, we know that we are doing geometric sequence from there now, and it's dealing with money. So one application of our geometric sequence in financial math is our compound interest. And this equation is very similar to our compound interest equation. This is the formula of our compound interest equation. Sorry, that should be P over here. And again, I'm writing R instead of R over 100 because my R is always in percentage. And N is how many months after. So you need to take note that the N over here is different from the N in the previous equation. And if we compare these two, we can see that my A is equal to Vn, my P is equal to A, my 1 plus R is equal to B, and my N is equal to N. So I need to identify these terms over here. And for part 1 is I complete the rule for Julie's investment after N months by writing appropriate numbers in the boxes below. So the balances is my A, and it's also my Vn over here. It's with the starting value. So my P is equal to 12,000 times my N. So I need to know what my R is. Now my R is the rate. My 1 plus R is equal to 1.0062. So this is my final equation. Part B, second part asks what would be the value of N if Julie wants to determine the value of her investment after 3 years. So we know that our N in here is in months. So 3 years, how many months is 3 year equivalent to? And there's 12 months in a year, so 3 years is 12 months. So that 12 times 3 equals 36. So my N is equals to 36. So next question. After 3 years, Julie withdrew this amount from her account to purchase a car. For tax, she planned to depreciate the value of her using the reducing balance method. So we have this equation over here. C0 is the initial value. Cn is equals to R times Cn. Cn plus 1 is equal to R times Cn. So this is also a geometric sequence over here. And then I know that N stands for number of years, and Cn is the value of our car in that after N years. So for each of the first 3 years of reducing balance depreciation, the value of R is equal to 0.85. What is the annual rate of depreciation in the value of car during these 3 years? So the value of R is equal to 0.85. Now I write down the equation again. So that's equal to A times R to the power of N minus 1, and we have that A equals to P times 1 plus R over 100, or just R to the power of N. I'll decide to write R here. So I know that my R, for the first 3 years, the R is equal to 0.85. So in this equation, my R is equal to 0.85. So my R over here is equal to 0.85. And we know that they are equivalent in the equation. So I know that my 1 plus R is equal to 0.85. Then my R2 from R, my number of R from the second equation is equals to minus 0.15 or minus 15%. So the annual rate of depreciation in the value of the car during these 3 years is 15%. You can say 15% of depreciation. So you will be avoiding the fact that you don't know if you should write your minus sign there or not. Now part B. For the next 5 years, the annual rate of depreciation in the value will be changed to 8.6%. What is the value of the car in 8 years after it was purchased? Now, so after 3 years, so from the 4th years and onward, the rate of that has been changed. So what I'm going to do here is I'm going to list out the amount of money in all 8 years, but you can do it by shortcut that I will introduce later. So here I have my first term, and my first term is my C0, and the value of C0 is 14,000. And my second term, which is going to be my C1, is 0.85 times. Remember that my R is equal to 0.85 in the first 3 years. So 0.85, that's my R. That's equals to, so my 14,000 times 0.85 is equals to 11,900. And I'm going to write my third term over here. But in my third term over here, in my fourth year, so after 3 years, the rate, my R value has been changed. So the depreciation in the value has been changed from 15% to 8.6%. So the R of that, so the R over here, the capital R is going to be 1 minus 8.6%. And that's going to be 91.4%. Okay, so we are going to use our third terms times 91.4%, because that is equal to 0.914 here. I made a mistake earlier, so instead of times that by my 91.4% right now, I actually only have the value depreciated twice. So when I need to do another term, so I need to calculate my fourth term to make sure that the value have depreciate at a rate of 15% or for 3 times over here. So now from my fifth terms and onwards, it's going to be depreciate by 8.6%. So I'm going to times the second term to the first term by 0.914 here. So through the calculation over here, I found out that after 8 years, my the value of the car is $5,484.23. And the question asks us to round my answer to the nearest cents over here. So that's 2 decimal places. Then I'm doing it right. Now I'm going to show you instead of writing out each of the terms. So you can see that I made the mistakes over here, and there's involving a lot of calculations over here, how to solve it by the equation we have. And again, I'm going to show you how to solve this equation by these two equations over here. So first is our geometric sequence equation, and the second one is our compound interest rate equation. Let's look at our geometric sequence equation first. So this is the number over here, and we know that my A is the number of my starting term or the initial term. So we're going to find out, because my R or my rate over here is different, and we have two phases over here, two phases in this case. So we're going to solve it by stages. Now at our first stages, my R is equals to 0.85, and my initial value or my first term is equals to 14,000. And I'm going to find out my N is, now I know that it's going to be after 3 years. So my N minus 1 equals to 3. So you're going to be my nth term in this case, because my first term is actually C0. I want to find out what does C3 equals to for my first stage. So I need to find out what Tn is when my Cn equals to 4 over here. So C3, which is my Tn, so it's equals to 40,000 times R is 0.85 to the power of 3, because 4 minus 1 gives 3. So from that I have that C3 is equal to 8,597.75, which is exactly the same as my fourth term in this case. Now, so that's my first stage. Now my second stage, I'm still going to use the same equation, but my first term becomes my C3. And my R becomes 0.914. We explained why earlier. And now we want to find out what is C. So after another 5 years, so that's going to be, what is my C8 equals to? My and N in this case is so my N minus 1 is equals to 5. So I want to find out when my N is equals to 9. In total, because in total we have 8 years, so that's 3 years over here. For another 5 years, N plus 5. That's, but I want to find out what my money is at the 9th year. So my C8 equals to 8597.75 times 0.914 to the power of 5. Because the depreciation rate applied 5 times, so it's to the power of 5 over here. Now that value over there is equal to 5,484.23. Now you need to be aware that the index over here is 5. It's how many times that it's depreciated. It's not going to be n minus 1 over here because we are using a different r. So the r is not consistent in the 8 years. Okay, so we can't use n minus 1 as our index in this case. It has depreciated 5 times, so we need to put 5 over here. Now let's look at the compound interest equation. Like that, we still have that at 2 different stages. Our principal or starting value in the first stage is going to be 14,000. So 14,000 over here, and 1 plus r, that's equals to 0.85. The r over here is my depreciation rate, so that's minus 15% as we calculated before. And my n is how many years after, and that's 3 years after, so I just put 3 over here. And if you do the calculation, you'll find out that my after 3 years, so I would write 83 is equals to $8,597.75. And our second stage, our starting value, that's 88 over here, so after 8 years, our starting value becomes $8,597.75, and my depreciation rate here is 8.6, so that's 1 minus 8.6%, which is 0.914 to the power of 5. So after another 5 years, now the month is 5,484.23. So that's how you can solve these questions by 3 different methods. Now let's look at the next question over here. So Julie has retired from work and has received a superannuation payment of 492,800. Okay, so there are 2 options for her investment, option 1 and option 2 over here. Now, option 1, she could invest this in a perpetuity and she will receive this amount each fortnight for the rest of her life. So the amount of money she receives per fortnight is fixed. And if we have a fixed value, then we know that there's a common difference between them. So we're implying over here that we need to use the simple interest equation, or this is a arithmetic sequence. Now, at what annual percentage rate is the interest earned by this perpetuity? So we know that the simple interest equation is I equals to PRT, and or I stands for the amount of interest, P is the principal, so the money that she invests in, R is the rate, and T is the time. Okay, so it depends on how you want to work it as your rate. It's because it's asking the annual percentage. So if it's asking the annual percentage, we need to solve out for T. But let's not worry about that first. Let's just find out the rate at this stage. So what I want to do is I want to find out so the total money she's earning per fortnight is 887.04. So that's what my RI equals to. P is equals to, that's the money she invoiced or she put into the account. R is what we're looking for. Now to earn this amount of money, she need to wait for each fortnight, and each fortnight equals to 14 days. So I'm going to put T equals 14 in this case. Now from that, I need to solve for R, and my R equals to. Now, because the question asks what is the annual percentage, so this is the amount that she's the rate that for per day. So for per annual, we need to times the number by 365. So R times 365. The value on my calculation is 4.693%. Now in the answer it say 4.68. This is a sexfold difference in because of the calculator, and you can put 4.69 over here or 4.68. Depends on how many decimal places that you keep. Sorry, 4.68. Depends on how many decimal places you keep in the first part of your calculation there. 4.68. Now, the second option is that she's investing the same amount of money. Instead of perpetuity, she's earning an interest rate of fees per annum compounded monthly. Okay, so you need to know that the rate is per annum, so per year, and it's compounding monthly. The balance of her annuity at the end of the first year of investment would be this much. And it's asking what monthly payment in dollars would Julie receive. So when we get to these questions, this is not related to general math students at this moment, but for further math students, this requires you to use the financial solver in your calculator. Where in your calculator, your n is equals to 12 because it's compounded monthly, so so your term will be 12 terms, and your FV, so your final value over there. Sorry, not mean your PV, so your present value will be the starting value, so that's 492,800 there. And your I in percentage is equals to 4.32. And your present value, the sign of your present value is depending on whose account are you taking reference to. If you are taking reference, so at first, if you want to say that Julie have put this money into her annuity account, then in regard to her annuity account, this is the amount of money that it received in the present. Then the PMT, which is the money that Julie received, will go to her other account. So that's the amount of money has been taken out from the annuity account. Then it will be inactive. So in your calculator, it will equal to 2,800 something. But if you take your present value as negative, means that Julie is putting this amount of money into her annuity account. So you're taking Julie's current amount as a reference. Then your PMT will be positive because that's the amount of money that's been transferred from her annuity account to Julie's account. So and this is not applied to our general math students. Now the second part, how much interest would Julie annuity earn in the second years of investment? Run your answer to the nearest set. So to do that, I first need to find out what the balance in her account for the second year. Now Now to do that, I need to, in the calculator, I will put my PM1 as 13 and my PM2 at 24. So my interest in percentage is 4.32. And my PMT, if I put PMT as positive, then my PV need to be need to be negative. So the sign of my PMT and PV are always opposite. And my PY and CY are all equals to L. So from there, we will find out our balance. So our balance in the second year will be this number over here, and our the sign of my balance number is always equals to the sign of my present value. So now I know that my balance in the second year, balance in the first year, what I can do is I can find out the differences. So differences is so from the first one, take away the second one. That's so and first is to find out my balance in the second year. That's 467,131.14 and be a two balance in the second year minus balance in the first year. So my interest will be the payment minus the reduction over here. This is the reduction. So from there we find out the reduction. And the interest is payment minus reduction. And the payment in the second year, find out that in the first year is 2,800 per month monthly. So the payment in the second year would be the same as well. So that's 2,800 times 12 minus the reduction over here. The answer will be so this is the final answer.